Hello students, welcome to IMS GATE Academy. Welcome to GATE Score Booster for Manufacturing. Here I am going to present you what are the concepts which are useful for GATE Booster for manufacturing concept. Okay. Now here let me introduce myself. I am Vijay Kumar and finished my PhD and pursued my MTech in NIT Surathkal, and I have cracked All India GATE 347 rank. Okay. Now the motto of this GATE booster session is about to increase your confidence levels. Okay. Now whatever the preparation you are going now, so by this session we are just trying to enhance your confidence level as well as the grip on the topics what you have prepared so far. Okay, that is what the intention of this GATE booster session. And before going to start this session, I'm just give you briefly introduction about the manufacturing, how the manufacturing is going to be important for the GATE and how much weightage. Okay. Now let me talk about from manufacturing or production you may get so 15 to 18 marks. It's so among all mechanical subjects it is going to be a highest weightage. Okay, if you prepare production properly and perfectly, and along with that any three subjects like mathematics, aptitude, fluid mechanics or strength of materials, so that you are going to crack GATE rank in very easy way. Got it guys? Okay. Now here I'm going to present that some beautiful questions in manufacturing which enhance your confidence levels, and also your whatever the preparation what you have done so far, so that will be enhanced so far. Okay, so that is why I'm here. So this session will definitely, after the end of the session you will get good knowledge in the concepts as well as the good practice on the problems as well. Okay, now hope you understand. Let us go for the session. Now have a look on the question, that is calculate the filling time of the casting cavity. Calculate the filling time of the casting cavity given below. Okay, now here casting cavity is given. Okay, now for this casting cavity you are supposed to calculate the filling time. So what is this concept from the casting chapter? No. And from the casting you may get 2 to 3 marks. Sometimes you may get 1 mark question, and sometimes you may get one 1 mark question, one 2 mark question also. Okay. Now here in casting, if you take that, in casting you are going to get continuously repeated questions from core and core design, and also powering time calculations for the different casting cavities, and also solidification time for the casting cavities, and also riser design and casting defects. From these 5 concepts we are going to get a very good number of questions continuously. So I have collected the beautiful questions which you have ever seen, and that questions we are going to solve in this particular session. Okay, now let us see that calculate the filling time of the casting cavity given below. Consider G is consider G is, so 1000, 1 minute guys. Yeah. Yeah. Now let us go for see this casting cavity. What is the casting cavity given here? Okay. Now here filling time. What is our basic formula for filling time? Filling time is equal to, it is volume of casting. Volume of casting is divided by so Vmax into choke area. Vmax into choke area. Now this is what your casting cavity, and as you know that this is a runner and it is a sprue and it is a powering basin, all right guys. Okay. Now let us go for, see this, what is AC? As we know that AC means choke area. Choke area. So that is AC is equal to, it is a minimum of, area of the sprue, comma, area of the runner, comma, area of the in-gate. Okay. So choke area means among the all gating elements, this is a sprue area and this is a runner area. So now sprue area is AS and runner area is AR. But in the problem, sprue area and runner area is not given now. That is the reason why we consider AG only given. That is why here your choke area becomes as a, your choke area. So your choke area becomes as a in-gate area. Clear everybody? Understood guys? Now let us calculate that filling time of this cavity. Now total head is available is 35 and gating ratio, that means gating area is given and also cavity is also given. Okay. Now for calculating this cavity, I just divide the total cavity into 3 parts. Okay. So now first part is A, up to here we consider it is A. Okay. Now second part up to here we consider it as B, and so top cavity we consider it as a C. Okay. So I divided that total cavity into A into B into C. So if I suppose calculate the A filling time, B filling time and C filling time individually, if I add all the filling time of A cavity, B cavity and C cavity, so that I will get total filling time. Okay. Okay, right. Now here let us total filling time of the cavity. Total filling time of casting cavity. Casting cavity. All right. Now here total filling time, I'll say that total TT. Now here it is TA plus TB plus TC. So this is what your total filling time. We'll calculate individually. So first filling time of the cavity A, filling time of the cavity B, filling time of the cavity C will calculate. So good evening all, very very good evening. Thanks for joining all. Okay, so please concentrate on the session so that you will get good confidence level in solving the solidification time calculations and filling time calculations and riser design as well. Okay, so hope you understand. Thank you all. Right. Now let us first we'll go for calculating the filling time of the cavity. I gave you the formula, that the basic formula for filling the mole cavity is filling time is equal to, it is volume of the casting divided by Vmax into AC. Clear everybody? Okay. Now first we'll consider TA. So how to calculate the filling time of the cavity A, isn't it guys? Right. Now let us see if we observe that what is the volume of the cavity A. So area is given na, 30 by 30 centimeter square is the area of the first cavity and its height is the 10 centimeters. So that area into height, so that you will get volume of the casting na, and also AC is the AG. Now next Vmax we have to calculate. How to calculate Vmax? Maximum velocity of the molten metal in the casting in the gating system. So how can we calculate? So we have a formula that Vmax is equal to, it is 2 into G HT. Okay. Now here what is your HT guys? HT total head is available is 35. So now your HT is equal to 35 centimeter. Okay. All right. Now by using this we can calculate solidification time of A. So now shall I go for the next slide for calculating the first cavity filling time? Yes, right. Right. Filling time of cavity A. Cavity A. So that I can say that TA, that is equal to volume of casting is divided by so AC, that is AG into Vmax. Okay. Now let us go for this volume of casting. Volume of casting. What is guys volume of casting? Volume of casting, area 30 by 30 into 10 centimeter. All right. Now here volume of casting. Yeah. So volume of casting, area is 30 by 30 centimeter square and this one is 10 centimeter square. And then what is your AG? AG is given na? What is AG is given? AG is given 5 centimeter square. Okay, AG is given 5 centimeter square. So AG is 5 centimeter square under root 2G HT. 2 into, in the problem they mention, guys, what is that? G, consider G equal to 1000 centimeter per second square, isn't it? Right. Now from there it is 1000, my G is 1000 into HT. HT is just now we have discussed, that is 35. Okay, what is that? Here in the previous slide, this is your HT. Okay, this is your HT, guys. All right, everybody. Right, now let us go for, if you solve this, you are going to get, it is 6.8 seconds you will get. 6.8 seconds you will get. So now we have finished our filling time of the cavity A. So cavity A filling time we have finished. Now we have to calculate cavity B. So if you observe that, guys, so cavity A is filled with the top gate, isn't it? The gate is connected at the top of the mold cavity, isn't it? So that is the reason why here I use this formula. Now if you observe the cavity B, it is filled with the bottom gate. Why? Because the gate is connected at the bottom of the mold cavity. Yes, guys. So from the bottom of the mold cavity, the molten metal is going to be enter. Okay. Now here it is AS. Enter. So that is why here you are supposed to use the formula, bottom gate formula. Okay, right. Now solidification time of the B. Okay, it is a bottom gate. Now let us go for B cavity. B cavity is filled with the bottom gate. B cavity filled with the bottom gate. Yeah, B cavity is filled by bottom gate. B cavity filled by bottom gate. Okay, right. Now here bottom gate formula. So TB is equal to, we have derived na, in our class we have derived that, what is that? AM is divided by, AM is divided by AG into 2 root 2G, sorry. Let me write the formula again. Right. So it is AM is divided by AG into 2 root 2G and also it is total head under root minus, HT minus HM is your bottom gate solidification time. Yes, guys. Yes, guys. Okay. Right. Now, so let us substitute that formula values. What is the area of the bottom gate? Obviously, it is the area is 30 by 30. This cavity is also area is same. This area is same, but height is different. Height is, total height of the mold is, this is here HM. Here HM. Isn't it, guys? Now let us go for solving the substituting the values. Okay. Now I'll go for the next slide. Now TB is equal to, it is AM 30 by 30 and AG 5 and root 2G 2 into 1000 into HT. Total height is available head is 35 under root it is 35 minus height of the mold is 20, isn't it, guys? Okay. Now have a look on that. So area of the mold is 30 by 30 and height of the mold is 20 and total head is available is HT is 35 mm. So that is what I have substituted there. Right. Now if you solve this, you are going to get, it is 16.45 seconds. 16.45 seconds. Yes, guys. So to be also finished. We have calculated. So TA filling time, TB filling time. Now the challenge is coming to picture, that is, C. So how to fill the C? and what gate it is, whether it is a top gate or it is a bottom gate, that you have to decide. Okay. Now let us see that. So molten metal falling from here in the A cavity is the top gate. Molten metal is rising from the B is the bottom gate, right? Now up to here we got filled. Up to here we got filled. Now we have to fill this cavity. We have to fill C cavity, right? So here what is the gate for C cavity, guys? That is a challenge. So that is a challenge. Gate of the C cavity. Gate of the C cavity is this one only. But the thing is here, up to here it is already filled. From here we have to raise the molten metal. Yes guys, isn't it? Clear everybody? The molten metal has been filled up to B cavity. The molten metal has to rise from B to C. Okay. Now you have to decide what is the available head. What is the total head is available. Okay. Now total head is available is 35. But up to here it is got filled. That means here if you take this line, now from here it is 35. Up to 20 it is got filled. So what is available head here? Total head minus 20 centimeters, so that you will get total head. Clear everybody? Understood guys? It's a very important point. Most of the students doing the mistake here that, so what height they has to take? Okay, what height they has to take while calculating the velocity. That is the reason why here molten metal already filled up to B. From C you have to increase. Okay, that is why total head is 35 minus 20, so that you are going to get. Now I'll conclude that C cavity is also filled with the bottom gate, and the available head here is 35 minus 20, so that your height of the total head is 15 centimeter only. Okay. Now let me write that statement. Right. Next, C cavity is also filled with bottom gate. All right. C also filled with the bottom gate. Okay. Right. But total available head is you know what is that? So 30 minus 20, so that you are going to get your total head is 15 centimeter. Clear everybody? Yes guys. Now let us go for bottom gate formula. As we have discussed that bottom gate filling time is TC is equal to, it is again AM, area of the mold, is divided by AG into root 2G into, it is HT under root minus HT minus HM under root. Yes guys, this is what your bottom gate filling time calculation of the cavity. Clear everybody? Understood? Now let us area of the mold. Here should be very careful deciding the area of the mold. So now let us go to our diagram. Which shape it is guys? Which shape it is? C cavity. C cavity, which shape it is? Yeah. C cavity, which shape it is? Don't think that. Here it is a rectangular shape is given. A, B are the rectangular shapes are given. But the thing is here C is given cylindrical shape. So now you are supposed to calculate area is equal to pi by 4 d square. What is a d? D is given 20 centimeter na? Yes guys. So that is why here area you have to decide very carefully. Okay. Now let us go for our area. Right. Now area. Here it is a pi by 4 d square is 20 centimeter square is divided by AG is again 5. Oh my god, 1 minute guys, it is right. AG is again 5 into 2 into 1000 under root, into HT. HT is, we have calculated na, HT is 15 centimeter. So under root 15 minus HT is also 15. Okay. So minus, what is HM? Height of the mold. Height of the mold guys. What is the height of the mold? Height of the mold is 15 centimeter. Okay. Height of the mold is 15 centimeter. Right. Now here height of the mold is 15 centimeter. Now if you close that and if you calculate this, you are going to get, it is 10.88 seconds will get. 10.88 seconds will get. Okay. So this is how, if we add TA, TB, TC, so that you will get total solidification time of your casting cavity. Now let us go for our total solidification time. Here I gave you na. So now TA, how much you got TA? TA you got that 6.8 seconds. 6.8 seconds plus it is 16.45 and plus it is 10.88. So that you are going to get total solidification time 34 seconds, 34.13 seconds you are going to get. Okay. So hope you understand, all of you, this question. Okay. Now if you encounter these kind of typical cavities, so in one problem, actually in our class what we have done, so one cavity, either we'll take square cavity or rectangular cavity, or spherical cavity or cylindrical cavity we have done. But the thing is here, so I have clubbed the 3 cavities. So whenever you club the 3 cavities, how you are approaching the problem is the important. So if you approach like this kind of question, so that any kind of question will come in the pouring time calculation, you will rock. Right, guys? Okay. So that is the reason why I have selected this question. I keep one square, one rectangular, one cylindrical in one particular problem. If you solve these kind of questions, so that definitely your confidence levels in the production and especially casting filling time calculations, you will boost your confidence level. Okay. Hope you understand the question, guys. Okay. So now let us go for next question. Yeah. So first read the question, guys. 1 minute. Right, guys. Let us go for the next question. That is, question. Just read the question carefully. So a cylinder of 150 mm diameter, 150 mm diameter and 200 mm height is to be cast without any riser. Okay. So the cavity do not have any riser. Okay. Right. Next, the cylindrical is molded entirely in the drag of the green sand flask and is top gated. Do remember, guys. Okay. Based on the data, you are supposed to build your diagram, so that it will be very easy to solve the question. Okay, what is that? They said that casting shape is cylindrical one, which a diameter of 150 mm and height is 200 mm, is to be cast without any riser, and the cylindrical molded entirely in drag. So you have a cope and drag, na? So from there, cope and drag, so the entire cavity is in the drag only. Okay, next is the cope of the flask is 200 mm height. Cope height is given 200 mm height, and the height of the molten metal during pouring is 50 mm above the cope level. So here it is a cope. Now a tapered sprue employed, the gating ratio is 1.15, 1:1.5:2. The time taken to fill the casting cavity, neglecting energy losses, if the in-gate area is 400 mm square cross section. Now you are supposed to solve and you have to calculate the filling time of this cavity. Clear, everybody? Okay. Now let us go for solve this question. Right. Okay. Now based on the data, let me draw the diagram. So what is the, so here I'll draw the diagram, a rough diagram. Okay. As we know that it is a drag. Yes, guys, it is a drag and it is a cope and it is a cope. What they said, that a cylindrical shape, 150 mm diameter and 200 mm height. Okay. Now I'll take green. Right. Now cylindrical shape of the cylindrical shape of the riser, sorry, mold cavity. Okay, this is cylindrical shape. Diameter is how much, guys? Diameter is 150 mm. Okay, now height is 200 mm. So this is what the height is, 200 mm. Yes, guys. Okay, now here I'm not drawing that mm. All dimensions are in mm. You just consider that. Okay, right. Okay, now here it is a 150 mm. Now what they said that it is entirely keep in drag. So the cavity is kept entirely in drag, guys. Okay, right. Next is what they gave. The cope of the flask is 200 mm. So the height of this fellow here, height of the cope is 200 mm. They gave. Okay, this fellow is given 200 mm. Okay, and what next given? The height of the metal during pouring is 50 mm. That means the molten metal here, we have a gating system. Na? For pouring the molten metal, we have a gating system here. Now from here, the molten metal is going to be poured. Okay. Now this pouring height is 50 mm dimension. This pouring height is 50 mm dimension. Alright, guys. Next, the tapered sprue employed. Taper sprue is employed. And the gating ratio. What is gating ratio? Area of the proportionate area of the sprue, proportionate area of the runner, proportionate area of the gate is equal to, it is given 1:1.5 is to, sorry, it is how much it is? 1.1 is to 1 minute. 1 is to 1.5 is to and also 2, right? So in that, what is given? In-gate area is given. AG is given. Okay, AG is equal to how much, guys? 400 mm square. Clear, everybody? Up to here, clear, everybody? 400 mm square is given. Okay, right. Now for this cavity, you are supposed to calculate. For this cavity, you are supposed to calculate filling time. That means how much time the molten metal will take to fill this cavity. How much time the molten metal takes to fill this cavity. That is what we have to calculate, guys. Clear, everybody? Understood? So based on the given data, I plot the diagram. Okay, I just briefly explain this once. Have a look on that. What is happening? Cylindrical shape of the casting cavity is given, and that is entirely placed in a drag. That is entirely placed in a drag, and it is top gated and height of the cope is given 200 mm. Okay, and after that, so the molten metal, suppose say that this is a cope level, molten metal pouring from the cope level is 50 mm, isn't it? So from there it is pouring. Now, and also the area of the in-gate is given and gating ratio is given. From there you are supposed to calculate your filling time. Okay, your filling time you have to calculate. Clear, everybody? Okay, good Bhushan, very good Bhushan, very good Bhushan. So 8 seconds is the correct answer, but let me solve myself. Okay, good. Right, now go for this. Yeah, so what is our basic formula of filling time? Filling time is equal to, it is, 1 minute, I'll just reduce the pen size. Yeah. So filling time, 1 minute, guys, 1 minute, I'll be back. Right. Filling time TF is equal to, it is a volume of casting. Volume of casting is divided by, so AC into Vmax. AC into Vmax. Clear, everybody? AC into Vmax. Now, volume of casting. Volume of casting. So, what shape of the casting it is? Cylindrical shape. So, what is the formula for volume? Area into height. So, now let us calculate individually. Right. So, volume of casting. Volume of casting is equal to, it is cylindrical shape, na? That is why pi by 4 d square into h. Okay. So now where d is a 150 mm and height is a 200 mm. Okay. Now if you substitute the values, pi by 4, it is d is 150 square into h is 200, such that you are going to get your volume of casting you are going to get, it is 3534291.73 mm cube. 73 mm cube you are going to get. Okay. Now next decide that Vmax. Vmax is equal to, just now we have discussed that, guys. What is that? It is a 2 root g ht. 2 root g ht. It is ht, guys. 2 root ht. It is ht. Now it's a very careful, guys. Okay, 2 into g. What is the g you have to select here? Do remember, guys, always do remember one thing, that is whenever all dimensions are in mm, you are supposed to select your g is, g is equal to 9810, mm per second square. Okay, right. So whenever all dimensions are in centimeter, it is 981 centimeter per second square. Now, so if it is in meters, 9.81 meter per second square. So most of the students doing mistake over here, okay, while taking g. Now what g you are supposed to select here? Here your g is, all dimensions are in mm na. So if you observe that in the problem, all dimensions are given mm. Here it is mm, here it is mm, here it is mm. Everybody, everywhere here it is mm is given. Okay, that is the reason why here we are select to g is 9810 into ht. Decide ht. What is ht? Right, I'll go for the previous slide. Now ht, from where height the molten metal is falling. So molten metal falling from here na, molten metal falling from here. That is why here 200 plus 50 is your total head. 200 plus, so that it is going to be a 250. Okay, so you are supposed to consider molten metal from where it is going to be poured into the mold cavity. That height you have to consider while you are calculating the velocity of the molten metal. Clear, everybody? Understood, guys? Okay, right. Now go for that. Now my ht is here 250. Okay, under root, so that I am going to get my velocity is, so we'll keep the velocity like this. Okay, so next is what we have to calculate? AC we have to calculate. Volume of the casting we have calculated, and Vmax we have calculated, and AC we have to decide. Now let us go for that. AC, choke area is equal to, it is a minimum of all gating elements. That is, minimum of AS or AR. Oh my God, 1 minute. Now here it is AG, okay, among whichever is minimum, that you are supposed to select. Clear, everybody? Right. Now let us go for, let us go for C. Decide that AZ is given na, AS is to AR is to AG is equal to 1:1 point, oh my God, 1 minute. 1.5:2. Okay, so by this proportion we will come to know that whichever is the minimum, sprue area is the minimum na. So sprue area is the 1 proportion, runner area is the 1.5 proportions, and gate area is the 2 proportions. Now however we know that it is gating area is equal to 400 mm square, isn't it? So now I want to find out that which one is the minimum among the AS, AR, AG, right? From there I'll come to know that AS is the minimum. That is why AS is to AG is equal to, it is 1:2. Can I write like this, guys? So from there I can write it is AS is divided by AG is equal to, it is 1/2. Yes, guys. From there I know AG. Now substitute AG here. AS is divided by 400 is equal to 1/2. So from there AS is equal to, it is going to be a 200 mm square. 200 mm square. Clear everybody? Right. If I go for this one, 1.5 AR is to AG, so that I will get my AR also. So now let us calculate that also, so that you will get clarity. AR is to AG is equal to 1.5 is to 2, such that AR by AG is equal to, it is 1.5 is divided by 2. I know that AR, so AG is 400 na, so AR is equal to, it is 400 into 1.5 is divided by 2, such that you are going to get it is 200. Okay, so now here AR is equal to, you are going to get it is 300 mm square. Okay, now let us decide that AC is equal to minimum of, what is AS? AS we have found 200 and AR is 300 and AG is the 400. So which one is minimum? So AC is the 200 mm square. Clear everybody? Okay, now we got all the volume of casting we got, AC we got, and also Vmax we got. If you substitute all these for values over there, so that yeah, thank you Ajay, thank you very much. Okay, yeah, now let us go for volume I have calculated, choke area I have calculated, and Vmax I have calculated. Now let us substitute all the values, so that I will get the filling time. Okay, now go for this. My filling time is equal to volume of the casting. How much volume of the casting, guys? Volume of the casting is 3534.291.74 mm cube is divided by AC is equal to, it is 200 into under root 2 into 9810 into 250. So that if I solve that, I am going to get 8 seconds. Clear everybody? Yes guys, understood everybody? Yeah. Now here, what is the tricky in this question? What you are supposed to remember in your mind while you are solving this kind of question? Okay, that is a point I would like to highlight. Okay, right. See, however, you can solve that. If it is a single cavity is given, volume of the casting and choke area and Vmax you can calculate. But the thing is here, see, whenever they gave this gating ratio, how you are supposed to select your choke area? Among this sprue area, runner area, in-gate area, which one is your choke area? So among the all gating elements, sprue area, runner area, in-gate area, which one is the minimum that becomes as a choke area? Clear everybody? So for that they gave that this gating ratio. From the gating ratio, you are supposed to select your minimum choke area. After that, you are supposed to select here total height is, it is not a cope height. So from where molten metal is going to be fall, that height also you are supposed to consider in your solution. That is a tricky in the problem. That is the beauty of the question. Okay, from where the molten metal is going to be pour, from there you are supposed to select your height for calculating the, what is that, velocity of the molten metal in the gating system. Clear everybody? So that is why here the tricky of the question is selecting the height as well as selecting the choke area is the beauty of the question. Hope you understand this question, everybody. Clear everybody? Understood guys? Okay, so now have a look on this question. If you want to copy, then we will go for. And one more thing, very important thing is here selecting the G. So based on your given dimensions in the problem, you are supposed to select your G. If it is in mm, all dimensions are given in the mm, so that you are going to be select your G is 9810 mm per second square. If your G is if all your dimensions is in centimeter, that is why you are supposed to select 981 centimeter per second square. If it is in meters, then you go for 9.81 meter square per second. Clear everybody? So thank you. So go for next question guys. Okay, yeah. Now here guys, do remember in filling time, solidification time calculations, and also riser design, definitely you will get the question for the gate for 2 marks directly. How simple and easy these kind of question solving is, very easy. If you all learn the concept is very simple. So basic formula, if you remember this filling time, so that you will be able to solve the any kind of question. But the only thing is here, how to decide the volume of casting, how to decide the choke area, how to decide the Vmax. If you know these things, so that you are going to get your solution. Clear, everybody? Okay, right. Now let us go for next question. Yeah, have a look on this question, guys. Yeah. Now let me read the question. That is, calculate the dimensions of the sprue to avoid aspiration effect to feed liquid molten metal at a rate of 20 kg per second. The height of the sprue is 16 centimeter and height of the pouring basin is 9 centimeter and density of the molten metal is 7,800 meter cube. Okay, so you have to decide your dimensions of the sprue to avoid the aspiration effect. Aspiration effect, already we had been discussed that is whenever molten metal pressure falls below the atmospheric pressure, then outside gases try to enter into the gating system and that or react with the molten metal and form some defects and create some obstacle for the flow of molten metal. So that is why here, to avoid the aspiration effect, what kind of dimensions of the sprue you are supposed to use is the important thing. Clear, everybody? Okay, guys. Right. Now let us see what is given. So calculate the dimensions of the sprue to avoid aspiration effect to feed the molten metal of at a rate of 220 kg per second. Okay. Now let us draw the sprue. This is what the sprue. Okay. Now what is given? Sprue height is 16 centimeter. Sprue height is 16 centimeter is given. Okay. Next is what is given? Pouring basin. As we know that pouring basin is connected to the top of the sprue. Top of the sprue, from where the molten metal is going to be poured like this. Okay. Right. Now, so pouring basin height is given 9 centimeter. Yes, guys, 9 centimeter pouring basin height is given. What else given? So a rate of molten metal at a rate of 20 kg per second. So this much amount of the mass per second is going to be enter. Okay. Now here the mass of the molten metal enter into the gating system 20 kg per second. Right. Now mass flow rate of molten metal. Mass flow rate of molten metal. Mass flow rate of molten metal, that is equal to, can I say it is m dot molten metal. So mass flow rate is m dot, that is equal to, it is 20 kg per second. So per second 20 kg is going to be entered into the gating system. Okay. Now the density of the molten metal is given. So the density of the, how much density it is having given. Okay. Now density of molten metal, density of molten metal is given by, we'll select rho is the density of molten metal, that is given 7,800 kg per meter cube. 7,800 kg per meter cube. Yes, guys, all of you okay? Yeah, area for ratio is 0.8. Okay, good, very good. Thank you all. Thank you very much. Okay. Yeah, Bhushan, you can do that also, not an issue. Yeah, you can do also. But the thing is here, I explained step by step, that would be helpful for your GATE exam. Okay, even in your shortcut also, directly you can take AS is half of the gating ratio, half of the gate area. Directly 200 you can take and you can solve the problem. That problem maybe takes hardly 2 to 3 minutes. But the thing is here, I would like to, enhance the steps so that the people will understand well. Na? That is what my intention, Bhushan. Okay, good. Thank you. Right. Now here, so mass flow rate is given, density given. Now, can I calculate volume flow rate? volume flow rate Q is equal to, here mass flow rate is divided by density. Yes guys, mass by density you are going to get mass flow rate. What is the mass flow rate? It is 20 kg per second is divided by density is 7,800 kg per meter cube. All right, 7,800 kg per meter cube. So now here, but the thing is here guys, here my sprue height HS, sprue height is HS, pouring cup is height is HC. Okay, now my height is given centimeter, this is also given in centimeter. That is why I just converted my volume flow rate is also centimeter cube per second. Okay, kg will get cancelled now. So this meter cube will go up, meter cube per second will come, but I require centimeter cube per second. That is why here, convert this into centimeter cube per second. Converting units is very important. Most of the students are doing mistake here only. Okay guys, okay, right. Now here 20 kg per second is divided by 7,800 kg per 10 power 6 centimeter cube. Okay, isn't it? Now meter cube I converted into centimeter cube. From there I can write it is 20 into 20 into 20 into 10 power 6 is divided by 7,800, kg will get cancelled now. So centimeter cube will come up, so that you are going to get centimeter cube per second. Clear everybody? Hope you understand how to convert this. Now here your volume flow rate is equal to, here how can I write this is, the calculation of volume flow rate is 2564 centimeter cube per second. Clear everybody guys? Centimeter cube per second. I got this Q. Okay. Now let us go back to our what you have to calculate. Suppose if I select, I'll change the color. Wait a minute guys. Right. Now if I select, this is section 1, this is section 2 and this is section 3, I'll select. Okay. Now I have to calculate the top of the diameter of the sprue and also bottom diameter of the sprue I am supposed to calculate. Suppose say that this is I am saying it is D2 and this I am saying it is D3. So D2 dimension, D3 dimensions I am supposed to calculate. Clear everybody guys? Okay, right. Now from here what I am supposed to select? Okay, D2. Now Q is constant from at section 1 and also section 2. Okay. Now if I select, this is a area 2 and this is a area 3. So area 2 is the top of the top of the sprue area. A3 is the bottom of the sprue area. Right. Now here Q equal to, I'll write it is, right. Now Q is equal to, it is A2 into V2 is equal to A3 into V3. Yes guys. Now we have supposed to find out the A2. From there if I found the A2, so that it is possible to find out the diameter of the section 2, isn't it? Right. Now from there first I'll select that case 1, I'll select that Q is equal to, it is A2 into V2. Right. Now here, so what is Q here? Q is here 2564. Q is here 2564. So and then I'll write my A2 is equal to pi by 4 D2 square into V2 is equal to, V2 how can I write? It is, go ahead guys, back to our V2. I want velocity at this section. Now from here what is available head? 9 centimeter. What is available head here? 9 centimeter. So that can I write my V2 is equal to 2 into G into 9. Yes guys, right. So I can get V2. If I want V3, so total height 16 plus 9. Okay, like that. Right. So from here it is V2, I can write it is 2 into 981. Why I have taken 981? All dimensions are in centimeter. That is why I am going to select my G is 981. Now this is 9 under root. Okay. Now, if I solve this, I'm going to get my D2 is equal to, 4.95 centimeter. 4.95 centimeter I am going to get D2. Okay. Now, similarly, you select that second case Q equal to, it is, A3 into V3, right. Now, from there, so Q is constant, that is why 2564 is equal to, it is A3 pi by 4 D3 square into, V3. So, how to calculate V3? So, now let us go for calculating the V3. Right, V3. I want velocity at the section 3. Now, what is the total head available? 16 centimeter plus 9 centimeter. So that I'll get total height HT. So now here V3 I can write. V3 here is equal to 2G into, it is 16 plus 9, 25 under root. Okay, right. Similarly, go for that. Right. Now here under root 2 into 981 into, what is HT? Total head is available at the section 3 is 25. So that if you solve this equation, D3, you are going to get, 3.83 centimeter. 3.83 centimeter you are going to get. Okay. Now your sprue diameter is so T2 is equal to, it is 4 point how much guys, 95 centimeter, and your D3 is equal to, it is gonna be a 3.83 centimeter. Okay, so to avoid aspiration effect, your sprue should be top of the diameter of the sprue is 4.95, bottom of the diameter is D3 is equal to 3.83. So then only it is possible to avoid the aspiration effect. Clear everybody guys? Understood? So now thank you all of you for this question. Now we'll go for the next question. But here in previous question, I would like to highlight one thing guys, that is here this one, converting the values, that means you have to bring that your volume flow rate into centimeter cube per second. Now here kg per second is given, kg per meter cube is given. This meter cube has to be converted into centimeter cube. So that is why I have multiplied with the 10 power 6, and if I go for up such that it is going to be like this, so that your units will come under centimeter cube per second. Clear everybody guys? Understood? Right. Now let us go for next question. Yeah. Have a look on this question guys. Tirmal Reddy. Yeah. Small. Okay, guys, welcome back. A small technical issue. Okay, right. What is given? A cylindrical riser must be designed. For a given casting, you have to design one cylindrical riser. Okay, for that, you are supposed to design your riser. Design riser is nothing but deciding the dimensions of the riser. Okay, now what is the casting dimensions? 7.5 length and 12.5 is the width. Okay, 12.5 is the width and height is 2 centimeter. Height is 2 centimeter. Okay, this is what the casting. For this casting, you are supposed to design your riser. You are supposed to design your riser. Okay, now what they said, cylindrical riser you have to design. Okay, now riser, cylindrical riser, it's a side riser. Why I drawn it is a side riser, guys? Why I have drawn side riser? Why? Because D equal to H means it is a side riser. Okay, so side riser. Okay, so for this, this is what height of your riser. Okay, now this is a diameter of riser. Okay, so now either height or diameter you have to find. This is what your question. Clear, everybody? For a given casting, you are supposed to design your cylindrical riser which diameter to height ratio equal to 1. That is equal to height equal to diameter. Clear, everybody? Understood, guys? Now let us go for the calculating the first question. Calculate the mold constant. Okay, right. So according to the Bernoulli's rule, what happened? Solidification time is equal to, okay, according to the Bernoulli's rule, solidification time T is equal to, it is mold constant into volume of casting divided by surface area whole square. Isn't it, guys? Volume of casting is divided by surface area. Okay, what they ask you to calculate in the question? Calculate the mold constant K. Solidification time is given now. Solidification time for the casting is 1.6 minutes. Okay, right. Now here solidification time is equal to, so 1.6 minutes into is equal to, it is K into volume of casting. What is the volume of casting? This is how much it is? It is 7.5 centimeter, and this is your, what is that? 12.5 centimeter. Okay, now the height is how much, guys? 2. Height is equal to 2 centimeter. Okay, this is also in centimeter. All right, guys, this is also in centimeter. Now how to calculate the volume of casting? Volume of casting is equal to 7.5 into 12.5 into 2, so that you are going to get volume of casting. Clear, everybody? Right. Now let us go for, so volume of casting 7.5 into and 12.5 into 2, so that you are going to get volume of casting. Now surface area. Surface area of the casting you are supposed to calculate. What is the surface area of this? So this surface and this surface, total 6 surfaces are there. Now rectangular block surface area is equal to, how can we calculate that? Here 2 into 7.5 into 12.5 plus 12.5 into 2, 12.5 into 2 plus 2 into 7.5. So that you are going to get your surface area of the casting. Okay. So now it is whole square, isn't it, guys? Volume and surface area I wrote. Clear? And 1.6 is given. Now only unknown parameter is k. So if I able to solve this, so that I am going to get my k is equal to 3.26 minutes per centimeter square. Minute per centimeter square. Clear, everybody? So here only thing is, here you need to decide solidification time according to the Bernoulli's rule, T equal to mold constant into volume of the casting divided by surface area whole square, so that you are going to get this much amount. So volume of the casting means casting dimensions already given in the problem, right? So that is the reason why here I substitute the dimensions and I got the K. Clear, everybody? Right. Now let us go for, this is what the first question. So mold constant we have found, that is equal to 3.26 minutes per centimeter square. Now let us go for second question. What they asked in the second question? For the riser design, diameter to height of the ratio is equal to 1. That is d by h of the riser is equal to 1. Now what should be the dimensions of the riser? Use modulus method. Okay, right? We have 4 methods of riser design now. What is that? Keynes method, modulus method, and also naval research method, and also shrinkage volume consideration method. In that method, they are asking you to calculate that third method, modulus method, they are asking you to consider. So what is modulus method? According to the modulus method, modulus of the riser is equal to 1.25 times of the modulus of casting. That is what your modulus method. Okay, right. Now for calculating this question, you are supposed to remember your modulus method. Okay, right. Let me write that modulus method. Second question. Modulus method. Sorry, not exactly. I'll give you the statement, guys. According to modulus method, of riser design, surface area of the riser is a modulus, right? Sorry. Now it is gonna be a riser, and that is equal to 1.25 times of the modulus of casting. Modulus of casting, again, volume by surface area is a modulus. For this is for casting. Yes, guys, this is for casting. Clear, everybody? Right. Now, so if I take square on both sides and k on both sides, then what happen? Solidification time of the riser is equal to 1.25 times of the 1 minute, guys. Yeah, guys, sorry for the interruption, a small technical issue. Okay, right. Right. Now here, if I take square on both sides, now let us go for next slide. Now, so volume of the riser and surface area of the riser whole square is equal to 1.25 times of the volume by surface area whole square for the casting. Okay. Now if I take k on both sides, what happened? Okay. So if I take k on both sides, then what happened? It is gonna be a solidification time of the riser, na? Solidification time of riser is equal to 1.25 times of the solidification time of casting, isn't it, guys? All right. Now solidification time of the riser. So I'll take TR is equal to 1.25 into, solidification time of casting is given in the problem now. What is solidification time of the casting is given? 1.6 minutes. Okay. Now here solidification time of the riser is equal to, I can write it is 2 minutes. 2 minutes will come. Yes, guys. So after that solidification time of the riser. How can I write? TR is equal to, it is K into volume by surface area whole square for the riser. Yes, guys. Okay. From there, how can I write this? Solidification time of the riser is 2 minutes, and your K is we got that 3.26 na 3.26. Now for the side riser, volume by surface area is equal to, you will get d by 6 whole square. Okay. Now if you solve this, then you are going to get your d is equal to 4.7 centimeter. Okay. Now modulus of riser, volume by surface area is equal to volume of riser na. So that is the reason why here you are going to get it is d by 6. From there you can calculate your diameter of the riser is 4.7 centimeter. Okay. Now here your d is equal to here 4.7 centimeter. That is also equal to height. Yes, guys. Right. Now here I have written capital D. So now it is, take it as a small d, because we have considered it as a small d. All right. Now this is how you are supposed to select your answer. Okay. Right. Hope you understand, all of you, this question. Okay. So have a look on this question. What you are supposed to find out? So first you are supposed to find out mold constant. After that, by using modulus method, riser dimension you are supposed to decide. Clear, everybody, guys? Understood? Right. Now let's go for another question. Yeah, sure. I will send S1, no problem. I'll send. Okay, right. Now have a look on the next question, guys. Yeah, have a look on this next question. Riser design only. Read the question for 1 minute. I'll give you 1 minute time and read the question. Yeah, welcome back. Read the question. That is, determine the size of cylindrical riser. Determine the size of cylindrical riser. Determine the size of cylindrical riser for a steel casting of size. Casting size is given, guys. Casting size is given. That is 250 by 50 by 250 mm cube. When the casting is fed horizontally and the riser is side riser is given, guys. Side riser means here obviously we have D equal to H. Okay. For the steel, then A is equal to given 0.1, B equal to given 0.003 and C equal to given 1, guys. Okay. Now by using this, you are supposed to, by using that A, B, C values, you are supposed to know that what riser design method it is. Novel research method. Got it? Novel research method, where freezing ratio is given now. So freezing ratio, based on the freezing ratio, you are supposed to design your riser. Clear, everybody? Understood, guys? Okay, right. Now what is freezing ratio? Freezing ratio freezing ratio is equal to, it is A by Y minus B minus C, isn't it? Freezing ratio is equal to, it is A by Y minus B and minus, where Y is a volumetric ratio, where Y is a volumetric ratio. So what is volumetric ratio? That is volume of riser is divided by volume of casting. That is volume of riser is divided by volume of casting. Volume of riser divided by volume of casting. That is why in short form I wrote that VR by VC. Clear everybody? Yes guys, you are following? Please comment on the comment box. You are following guys? Okay. Good. Thank you all. Thank you. Right. Now, freezing ratio can also write, freezing ratio. This say that is equation number 1. Okay. Right. Next is freezing ratio. Freezing ratio is equal to, we can also write it as, modulus of riser is divided by modulus of casting. Okay. So what is that? Modulus of riser is divided by modulus of casting. Modulus of casting. Okay. Right. Now what is modulus of riser? Volume by surface area of riser is divided by volume by surface area of casting. Volume by surface area of the riser divided by volume by surface area of the casting, isn't it guys? Okay. Now as we know that, so both are the freezing ratios only, na? So I just equate that. Okay. Now it is A by Y minus B minus C is equal to, it is volume by surface area by riser, and volume by surface area of the riser is become as a D by 6, and modulus of casting, volume of casting dimensions given, na? What is casting dimensions? Casting dimensions are given 250 by 50 by 250. Okay, right. From there I'll write it is volume of the casting 250 by 50 by 250 is divided by, surface area 2 into 250 by 50 plus, 50 by 250 plus 250 by 50, 250, right? Such that you are going to get this. This is all the denominator and it is a numerator. Okay, right. Now A value is given na 0.1 and divided by volume of the riser is divided by volume of the casting, minus B is 0.03 minus C is 1. Now, so write that D by 6 is divided by the entire equation again, that is 250 by 50 by 250 is divided by 2 into 250 by 50 plus 50 by 250 plus 250 by 250. Okay, right, like that you are supposed to do. Now if you solve this equation, you are going to get your D is 128.4 mm. So D equal to 128.4 mm. Okay. Now here your volume of riser is pi by 4 D square and your volume of casting is this much 250 by 50 by 250. Now if you solve this equation for D, so that you are going to get your D is equal to 128.4 mm you are going to get. Clear everybody guys? Understood? Now solve this. Volume of the riser pi by 4 D square H. Cylindrical riser na? Right. Here I can write it as if you want. Volume of riser is equal to pi by 4 D square into H, where D equal to H na? So that is why directly you can write volume of riser equal to pi by 4 D cube. So if you substitute pi by 4 d cube here and volume of riser is 250 by 50 by 250, then you just go for this and solve the equation for d, so that you are going to get d is 128.4 mm. Okay, hope you understand the solution, guys. Now let us go for next question. Right. Now we just shift our talk on to welding. Before we are shifting our talk on to welding, I would like to summarize the session, what we have discussed so far. Okay, right, guys. In casting, we have I collected the problems of filling time calculations, 2 questions, and also solidification time question, 1 question, and also riser design is 2 questions. Okay, most of the times the questions are coming from filling time, solidification time, and also riser design time. That is the reason why I have collected these typical questions for you guys. I hope in casting, which are your preparation now, these questions definitely boost your confidence levels. Okay, I hope you understand. Thank you. Now let us move for the welding. Right. Now, before going to welding, we just have a small summarization of the welding. Okay. So, in welding, we may get one 2-mark question. Okay, weightage of the chapter of the welding is 2 marks. Okay, right. Now, in that, what are the continuously repeated models are coming? That models I have collected for this session. Definitely, I hope you enjoy the problem collection as well as the concepts which we are going to use for solving the problems, and basics in the problems also you will be able to understand properly. Clear, everybody, guys? Okay. Now let us go for solve this question. Okay, right. See that the voltage arc length characteristic of a direct current arc is given by, so voltage arc length characteristic is given 20 plus 40 L volts, 20 plus 40 L volts, where L is the arc length in centimeter. The power source characteristic approximately by a straight line, with an open circuit voltage of 80 volts, and short circuit current of 1000 amperes, What we have to determine? Determine the optimum arc length and the corresponding arc power. So, optimum arc length and also optimum arc power you are supposed to find out, guys. Okay. Now have a look on this question. What is given? Here arc length characteristic is given, and also linear characteristic is also given. Linear characteristic we also consider it as a VI characteristic, isn't it, guys? Yes? Okay, right. So now voltage given by arc length characteristic. Okay, voltage given by arc length characteristic. Let me write given data. Voltage given by arc length characteristic. Voltage given by arc length characteristic. Yes, guys. Now what is given? VA. For avoiding the confusion, arc length voltage given by arc length characteristic is VA equal to 20 plus 40 L. 20 plus 40 L. So small l they have taken. That is why we will also take small l, guys. Okay. (20 plus 40 L). What is given? Arc length characteristic voltage is given, and the power source characteristic. Approximated by a straight line. So what is a power source characteristic of straight line? Okay, this is what? Yes, guys. Now we have decided now. So arc length characteristic voltage is given by, what is that? I'll write it statement and then we'll go for that. Right. Now VI characteristic or linear characteristic, VI characteristic voltage, VI characteristic voltage. So that is what is the, we can write it as V by V naught plus I by IS is equal to 1. Yes guys. Okay, from there I can write it is V equal to, it is 1 minus I by IS into V naught. Yes guys. Okay, now it is a voltage given by the VI characteristic. Yes guys, VI voltage given by the VI characteristic. But at equilibrium, VA equal to V, isn't it guys? VA equal to V. So that we will see later. Power equation is equal to, it is power equal to V into I na. So now what is my V? This much. Okay. Now I'll take the space. Okay. Now power equal to, it is V is how much I got? It is 1 minus I by IS into V naught into I. Yes guys, I just substituted this V value in this equation, okay, such that I am going to get this equation. Now send it at us, as we know that in the problem they gave that open circuit voltage and short circuit current, isn't it? Open circuit voltage, what is that? V naught equal to 80 and short circuit current is equal to 1000 amperes given in the problem. Yes, right. Now I send I inside, that is equal to I square minus, sorry, I only, I into I minus I square by IS into V naught. Now send V naught inside. So V naught into I minus V naught by IS into I square is your power equation. Substitute V naught and IS values. Substitute and V naught and IS values. What is that V naught? V naught is a 80I minus V naught is 80 and IS is 1000, okay, into I square, isn't it? This is what your power. Alright guys, for optimum power, let us go for optimum power. For optimum power, so what is happening? dP by di is equal to 0. For optimum power, dP by di equal to 0, isn't it? That is what we have discussed now, right? Now for that, d by di of, okay, so what is power equation? 80I minus 80 by 1000 I square is equal to 0. So now derivation in terms of that, 80 minus 2 into 80 into I is divided by 1000 is equal to 0. From there, how can I write this? So this 0 will get cancelled. Now 80 minus, it is 16 by 100 into I is equal to 0. From there, 80 is equal to, it is 16 by 100 into I. From there, I can write my I equal to, it is 500 amperes. 500 amperes I am going to get my I. Okay. Now from there I know that equation that V equal to, it is V naught, V equal to, it is 1 minus I by IS into V naught. So I know na. So from there 1 minus I is, how much you got? 500 and my short circuit current is 1000 is into 80, such that 80 minus, okay, it is 80 into 500 is divided by 1000, isn't it guys? Now so 2 2's will get cancelled. Now here it is 80 minus 40, such that my voltage is equal to 40. Yes guys, right? Hope you understand. Now I got I and also V. Okay, right. Now let us go for at equilibrium condition. I said that it is VA equal to V na. Now, so I got VA. What is VA? VA is 20 plus 40L, that is equal to 40, right? So from there 40L, V equal to 40 now, is equal to, it is 40 minus 20. Now L equal to, it is 20 by 40, that is gonna be a L equal to 0.5 centimeter. Okay, so optimum L equal to, L optimum is equal to, it is gonna be a 0.5 centimeter. Clear everybody guys? Understand? Right. What is optimum power? Optimum power is equal to V into I. So V is 40 volts and I is 500, such that I am going to get, it is 20,000 watts. So I can write it is 20 kilowatts. I can write this is 20 kilowatts. Clear everybody guys? So hope you understand the solution. Okay. Now what you are supposed to find here? So optimum arc length and also optimum power. Right. So now shall we go for the next question? Right. Yeah. Have a look on this question. I'll give 1 minute time to you guys. Yeah, welcome back guys. Right. Have a look on this question. Now most of the times the question also repeating from here, that is you know uh, a resistance welding process. Okay. Now let us go for this one. Right. Two sheets of low carbon steel 1.5 mm thick, 1.5 mm thick each, spot welded by passing a current of 10,000 amps for 5 cycles in a 50 hertz of main supply. Okay, 50 hertz of main supply. Okay, next up, what is we are supposed to find? What is the heat generated due to the supply of power if effective resistance is 200 micro ohms? Okay. Right. So if I supposed to select a 200 micro ohms, so micro ohms and also 1.5 mm thick steel sheets and current is 10,000 amperes, 5 cycles in 50 hertz, then what will be heat generation happen during the welding process, that I am supposed to calculate. Clear everybody? Okay, right. Next is second question. The maximum indentation is 10% of the sheet thickness. In sheet thickness, maximum indentation is 10%. Now, density of the spot welded nugget is 8 gram per centimeter cube. Okay, nugget, that means a sheet, whatever the material you are using for the spot welding process, that material density is given 8 gram per cc. Now, if the 1380 joules are required to melt 1 gram. So, for melting 1 gram, you require 1380 joules. Then determine the heat required for welding operation if diameter of the nugget is 6 under root T to determine the nugget diameter D, and assuming nugget size is to be equal to the material between the two electrodes. Clear everybody guys? Okay. Now, you are supposed to calculate heat generation in the machine welding operation as well as the heat generation in the heat required for the welding operation also you have to find. So, first you write that given data so that you will get some clarity what you are supposed to find. Okay. What is that? 2 sheets of carbon each of 1.5 mm thick in is spot welded. Okay. I just draw 2 sheets which are having 1.5 mm thick sheets. Okay, these are these thick sheets which are having thickness of 1.1 mm. Right, so it is having 1.5 mm thick. Okay, this is also 1.5 mm thick. Okay, these are going to be spot welded. So, by using the current of, how much current given guys? Current is equal to, it is 10,000 amperes. Okay. Next is how many cycles? So, 5 cycles. 5 cycles in 50 hertz of current. 50 hertz of current. Okay. Now, so if effective resistance, so resistance is equal to it is 200 micro ohms. Okay, 200 micro ohms. If I want to convert the micro ohms into ohms, then I am supposed to multiply with the 10 to the power of minus 6. Now here it is gonna be a 200 into 10 to the power of minus 6 ohms. 200 into 10 to the power of minus 6 ohms. Clear everybody guys? Okay, right. Now this is what the given data. Now, next, the maximum indentation is 10% of sheet thickness and density of the spot welded nugget is 8 gram per cc. Okay. Now, what they said that, they are telling that, I'll take, right. So, 10% indentation is going to be taking place. Now, this is 10% indentation is going to be takes place. Okay. So, these are the electrodes. Okay. Now, this is what the electrode, and these electrodes are indented into 10% guys, indented into 10%. And so, nugget density is also given. Okay, right. Now, the nugget diameter you have to find like that, and diameter, assume that nugget is size is equal to a metal between the two plates. Okay, right. Now, let me draw that. Now, nugget shape is like this. Nugget shape is 1 minute. It is a cylindrical one guys. Cylinder shape of nugget will be formed. Now, the density of the nugget is also given. Density of the nugget is equal to, 8 gram per cc. 8 gram per cc. Yes, guys. Okay. Now, what we have to find? So, for forming this nugget in between these two sheets, how much amount of the heat we require? And what is the amount of heat is going to be generated? In the first question, you have to calculate heat generation. In the second question, you have to calculate heat required for this fellow. Okay, right. Now, let us go for calculating that. So, in resistance welding, I said that the heat generation is equal to, how can we write? Heat generation Hg, I consider it is equal to, it is I square RT. Isn't it guys? I square RT. Clear? Right. Now, let us go for I. I is given na. So that is 10,000 square into or 200 into 10 to the power of minus 6 ohms. Now T is not given. T is not given. 5 cycles and 50 hertz is given na. Right. Now time equal to, here I'll side time is equal to, it is 5 cycles is divided by 50 hertz, such that you are going to get, it is 1 by 10 and seconds it is. Okay, now it is going to be a 0.1 second. Now here T is equal to time, that is 0.1. Now heat generation is equal to, you are going to get 2000 joule you are going to get. 2000 joule you are going to get. Yes guys, clear everybody? Heat generation we have found. This is the first question, right? Heat requirement, right? So what is heat requirement? What is the amount of heat required for melting this nugget? Okay, so for that purpose, so what is they said? For melting 1 gram, you require 1380 joules of heat. All right, are you getting my point? 1 gram of nugget, if you want to melt, you require 1380 joules of current. Okay, joules of heat. Right. Now, so how many grams are presented here? How many grams are presented here? That is what you have to calculate now. So for calculating that grams, that means mass of nugget, how can I write that? Volume of the nugget into density, so that I'll get my nugget mass na. So how much of the mass of the nugget? That is volume of the nugget into density of the nugget, so that I can get my mass of the nugget. So suppose say that I got some 10 grams of nugget I got. For melting 1 gram, I require 1380 joules. So that if I multiply my mass of the nugget into 1380 joules, so that I can get my heat requirement na. Are you getting my point? So what I'm trying to explain you guys, for melting 1 gram of nugget, you require 1380 joules of the heat. If I able to calculate my mass of the nugget and multiply with this 1380 joules, so that I can get my total heat required for forming this nugget. Clear everybody? So that is the reason why here we can consider it as a, this is called melting energy. Okay, melting energy, unit melting energy. That means for melting 1 gram, how much heat energy you require is come under unit melting energy. Okay, or how much, yeah. So what I'm trying to explain you here, so 1 unit of volume or 1 unit of gram. Thank you Arun, thank you very much, keep doing, keep watching. Okay, right guys, right. Now here what I'm trying to explain you, for melting 1 gram or 1 unit volume, how much heat you require, that is come under unit melting energy. Can I say that this is my unit melting energy? Yes, for melting 1 gram, I am required, so 1380 joules, right? Now here, let us calculate this mass of the nugget. For calculating the mass of the nugget, first I require volume of the nugget. So it is a cylindrical space, its height is h, and this is what? D, right? So how to find out D? D you can find out here, right? And one more thing they said that, okay, assume that nugget size is equal to be metal between the 2 electrodes. Metal between the 2 electrodes means, so all electrode already penetrated into 10% into the thickness. That is why here if you remove 10% here, if I remove 10% here, so that your height of the nugget will come now. Isn't it? Height of the nugget can be calculated by removing the 10% indentation of electrode, 10% indentation of electrode top and bottom, so that I can get my nugget height. Yes. Now diameter I can calculate D into 6 root to T. So T is the thickness of the sheet, isn't it? Now so that I can get my volume. Volume into density, so that I can get mass of the nugget. Yes guys, clear everybody? So no confusion at all. Okay. So I'll write each and every step in the next slide, not any problem. But here what you need to understand here they said that the maximum indentation is 10% of sheet thickness, and so that upper electrode is indentation 10%, bottom electrode is also indented into 10%. So that from 1.5, 10% if I deduct, from 1.5, 10% I deduct from the bottom side so that I can get my height. Why? Because they said assume nugget size is equal to be metal between the two electrodes. Metal between the two electrodes means this much. Okay, clear everybody guys, right? Now let us go for, hope you understand this. Now let's, heat required for melting, heat required to melt a nugget is equal to, it is mass of nugget into unit melting energy. Unit melting energy. Unit melting energy, right? So first you write unit melting energy. What is unit melting energy? Unit melting energy. Unit melting energy is equal to 1380 joule per gram. So for melting 1 gram, you require this much amount of the heat. For what is the mass? What is my total mass of the nugget? So for that, getting mass of the nugget, volume into density of the nugget. Okay, now let us go for volume of the nugget. Volume, sorry, not volume, mass we'll calculate. Right. Now here, mass of the nugget. Mass of nugget is equal to M, I say, that is equal to volume of nugget into, so density. So density of the nugget is given now. What is density of the nugget given in the problem? Density of the nugget is, where is here? Here it is 8 gram per cc, right? Now let us go for density is that much. Now volume of nugget, it is a cylindrical shape na, pi by 4 d square into h into density is 8 gram per cc. Yes guys, clear everybody? So from there, d, how can I find? D is equal to, it is, d is equal to, it is 6 root t, that is 6 into root t is 1.5. Excuse me guys, 1 minute. Mm. 1.5, such that you are going to get it is d equal to 7.34 mm. 7.34 mm. But do remember guys, very careful in units, that is here density given gram per cc, centimeter cube given, right? That is why convert your dimensions also centimeter, 0.743 centimeter. Clear everybody? Right. Now let us decide that what is h. What is h? So h is equal to, I'll write diagram again. So because it is very important how to decide the height. Okay, right. What they said in the problem? Guys? The electrodes are indented into 10% of the thickness, right? Now here the electrode indented 10% of the thickness. Okay. Similarly here also 10% indented into the thickness. Right? Right, 10% indented. Now what is my height of the nugget? I'll take another ink. Now my nugget height is, this is what my height, isn't it guys? Now how can I guess my height? How can I select my height? Now let us decide this. Right. Can I write my h is equal to, it is 2 into thickness of the sheet minus 2 into indentation. Okay, this is what indentation, na? 10% indentation, isn't it, guys? Yes or no? Right. Now, what is my thickness? My thickness is, here it is 1.5, here it is 1.5, right? Now, here indentation in what? 10% in of 1.5, 10% of 1.5, isn't it, guys? So, I walk with Vijay sir. Yeah, thank you, Rakesh. Thank you, Rakesh. Thank you very much. Okay, yeah, right. Now here, let me decide that 2t, 2 into 1.5 minus 2 into indentation. Now indentation here, what, guys? Okay, here 10% of indentation here, 1.5 and 10% is 0.15. So top 0.15, bottom 0.15, isn't it, guys? Now here it is gonna be a 3 minus, so 0.30, so that you are going to get your height of the nugget is 2.70 mm, because we have taken it is mm, na? 1.5 is mm, 1.5 is also mm. So now here, guys, very careful, indentation. How much indentation? 10% of top side, 10% of bottom side, 10% in that. So what is the 10% in that? 1.5 into 10 by 100, isn't it? So now here, so will get cancelled. It is gonna be a 0.15. So 0.15 mm is going to be indented in the top side, 0.15 indented into the bottom side. So that if I deduct my bottom side indentation, top side indentation, so that I can get my height of the nugget, na? Isn't it? That is the reason why here indentation, top side and bottom side, both side is 2. That is why 0.15, and it is going to be a 0. It is not 8, guys. It is right. Now it is no. Let me erase this. Right. Now here it is 0.30. So that now here D we have taken in centimeter. That is the reason why this fellow also you take in centimeter. That is equal to, it is going to be a 0.270 centimeter. Okay. Now we got the dimensions of the cylindrical nugget, which is formed in between the two electrodes. Now if I multiply my volume of the nugget into density, so that I can get my mass of the nugget, right? If I multiply my mass of the nugget with the unit melting energy, so that I can get my total energy, heat energy required for melting or forming of that nugget, na? Yes, guys, are you getting my point? So very simple logic. I am calculating the total mass of the nugget, and then if I multiply with the unit melting energy, suppose say that they said that for 1 gram they require say that unit melting energy, for melting 1 gram you require 1380 joules, right? Now in that case, if I able to calculate my mass here, so that my mass into my unit melting energy, so that total heat required for forming this nugget, isn't it? Right. Now that is why for getting the mass of nugget, volume of the nugget I am calculating by using the diameter, by using the height, and then density, so that I can get mass of the nugget. Right, guys? Now let us go for calculating the mass of the nugget. As we have derived all the dimensions of the all the values of this one, na? So D we got, H we got, and also density we got, so that we will get the mass of the nugget. Now let us go for that. Mass of nugget is equal to M. It is equal to pi by 4 D square into H into 8 gram per cc is the density. So that volume into density is a mass. Okay. Now pi by 4 into, it is D is how much, guys? D is 0.734 whole square into, H is 0.27 into, 8 gram per cc. Clear, everybody, guys? Okay. Now here mass of the nugget I am going to get, it is mass of the nugget thus much. Okay. Now total heat required. Right. Total heat required. total heat required to form or to produce nugget, that is equal to, here it is, mass of the nugget into unit melting energy, right? From there, what is the mass? Pi by 4 into 0.734 whole square into 0.27 into, it is 8 gram per, oh my god, 1 minute. Eight gram per cc into unit melting energy 1380 joules per gram. Okay, from there my heat energy required, I am going to get 1264 joules. I am going to get. Clear, everybody, guys? Okay, so hope you understand this solution. Okay, so very simple, guys. So don't think that most of the students by seeing the data, it is quite tricky. Okay, all the thing is you need to do that, read the problem once and twice, guys. Okay, whenever you encounter with a problem, then immediately you write the given data. And if it is possible, within the available data, you just frame a small diagram so that it would be very, very easy to you to solve the question. Okay, see that how simple it is. They said that 10% indentation, you just remove 10% indentation from the top and bottom so that you will get the height of the nugget. And diameter, they gave that in the formula itself. So diameter, height, if you know that it is a cylindrical shape, volume you can calculate. Volume into density, so that you will get mass. So for 1 gram melting mass, you require 1380 joules. So total mass you calculate of the nugget and multiply with the 1380 so that you are able to get the total heat energy required for the forming the nugget or producing the nugget. Okay, here one question for heat generation, that we have calculated direct formula. What is that? Direct formula, heat generation equal to I square RT. So now T is given, 5 cycles by frequency given, cycles by frequency, so that you will get time. Okay, now here time is equal to seconds. Now substitute that, you will get now heat required is equal to heat required for melting the nugget or producing the nugget is equal to mass of the nugget into unit melting energy. What is unit melting energy? So for 1 gram melting, how much joules you require, that is what is come under unit melting energy. Sometimes unit melting energy may be mentioned in the volume also. Suppose say that unit melting energy 1380 joules per mm cube. That means for melting 1 mm cube, you require 1380 joules. In that case, you just only calculate volume into unit melting energy, so that you are going to get total heat requirement. If some cases mass is given, unit melting energy given in terms of mass, you have to calculate the mass of the nugget. If unit melting energy given in terms of volume, you have to calculate mass of the volume of the nugget. Got it? That is what the simple logic. Okay, clear, everybody, guys? Now, so heat requirement I have calculated like this. Now I guess mass of the nugget I have calculated by using the volume of the nugget into density, so that I get my mass. Once I get for getting the volume of nugget, I have to decide my diameter of the nugget and also height of the nugget. Diameter, height I have calculated, and height they gave the clue that 10% indentation from the top side, 10% indentation from the bottom side. I just remove the 10% from the thickness of both sides so that I can get my height. Height into height, diameter I got, volume I got, density given, mass I'll get. Once I'll get my mass, I just multiply unit melting energy so that I can get total heat required for melting or producing that particular nugget. Clear, everybody, guys? Okay, so hope you understand, all of you. Yeah. Now, whenever these kind of tricky questions, if you encounter small concept, that means the same related solution problems we have done in our class, but directly we have got that one shape, either square shape or spherical shape or cylindrical shape of the nugget we have solved. But if we have ever encountered this kind of indentation percentage. If you encounter this kind of indentation, so that you will be able to so very simply, easily you can go to solve this kind of questions. Okay, guys, hope you understand. Now let us go for the next question. Yeah. Read the question, guys. I'll give you 1 minute time. Right. Welcome back, guys. Welcome back. Now let me read the question which is related to the welding. Okay. Right. Now, yeah, see that weld is made using MIG welding process with the following welding parameters. Okay. MIG welding means metal inert gas welding or gas metal inert gas metal arc welding. Okay. Now, metal inert gas welding process with the following welding parameters. Current is given, guys. Current is, oh my god, 1 minute. Yeah, thank you Pragya sir, and thank you Chandrababu sir. Thank you very much. Thank you very much all. Okay, right. Now, so current is 200 amperes, voltage is 250 volt. Oh, 1 minute, some technical issue, guys. Right. Now, here current is 200 mm, so, sorry, 200 amperes, voltage is 25 volts, welding speed is 18 centimeter per, oh, why it is giving, yeah, welding speed is 18 centimeter per minute, wire feed rate is 1.2 mm, oh sorry, wire diameter. Next, wire feed rate is 4 meters per minute. The thermal efficiency is 65%. Okay. Now, what we have to calculate? So, we have to calculate that heat input per unit length of that is in terms of kilojoule per centimeter is we have to find, and also area of the cross section of the weld bead you are supposed to find. So, as I said earlier that, so whenever you encounter or engaging with this kind of problem, you just write given data. Whenever you write given data, so that your mind will go to your notebook. Okay. So that what are the discussion we had made in the classroom, then that will all float into your mind. Then immediately you will find that what is a missing parameter in that particular topic. That is why always keep telling you write given data whenever you go for solving the problem. So that once you write the given data, you will think yourself, so that you will find out that what is the missing one. So accordingly you can find that missing parameter. Clear, everybody? Hope you understand. Right, let us write the given data. So a MIG welding is going to be happen, and it is following the parameters of current. So what is the current, guys? Current is equal to, it is 200 amperes, and voltage is equal to, it is 25 volts. Okay. Now what is given? Welding speed is given. So welding speed V, small v I am taking, guys. So welding speed is equal to 18 centimeter per minute. 18 centimeter per minute. Next, wire diameter. Wire diameter. That is equal to, it is 1.2 mm. Okay. Next, wire feed rate. Wire feed rate I am taking it is F, and wire diameter I am taking it is D, guys. Okay. Right. Now, what is feed rate? 4 meters per minute. 4 meters per minute. Okay. So do careful in writing the relations. Okay. Thermal efficiency. So eta T is equal to, it is 65%, guys. Okay. This is what given. Now we have to find heat input. Clear, everybody? Heat input. Thank you Chandrababu sir. Okay. Right. Now, so first of all, you have to see that what is MIG welding. So how it is going to be look like. Okay. Now I just give you the brief diagram for that. Accordingly, you can able to understand that. Okay. Right. Okay, let me erase this and draw it again properly. Right. Now, here it is happening. Now, in MIG welding, what happened? Na? In MIG welding, what happened? Na? So, a wire is continuously feed into the weld region. So, this is what the welding we are supposed to do. Now, a wire is going to be continuously feed into the weld region, okay, with the help of rollers. Now, this is going to be melt. This is going to be melt. Right. Now, 1 minute, I'll take another ink. Right. Now, this is going to be melt and supply molten metal into the weld region. Isn't it, guys? Okay. This is what happening in the MIG welding. Okay. Now, here, this is what your weld bead. Right. Okay. Right. Now, here, electrode. Here it is a electrode is going to be feed into the weld region. It is a electrode, isn't it, guys? Now this electrode is continuously feed into the weld region. Okay, right. Now, so they are using some parameters. Right. Now they are using some parameters. How much feed rate they gave, and what is the welding speed they gave. Okay, what is the welding speed they gave, and what is the current used, what is the current is used, and what is the voltage is used for this process, and also thermal efficiency also given. Okay, now what we have to find in the first question. Okay, first question we have to find out heat input per unit length of the weld in kilojoule per centimeter. Clear, everybody? Right. Now here heat input is equal to it is V into I into thermal energy, thermal efficiency is divided by welding speed. Welding speed, isn't it? Now what is V and what is I? Now what is V and I? V is 200, V is 25, I is 200. Yes, no? So I is 200, V is 25. Right. So V is 25 and I is 200 into thermal efficiency 0.65 is divided by welding speed. How much gave welding speed, guys? Welding speed is 18 centimeter per minute. Okay, 18 centimeter per minute. Now here 18 centimeter per minute. Yes, guys. Okay. Now here what are the units you will get at the top? What are the units you will get at the top? So at the top you are going to get watts, na? Watts. That is equal to watts or joule per second. Joule per second. Okay. Now let me write it properly. Right. Right. So here you will get at the top joule per second. Okay. Now it is divided by, it is gonna be a centimeter per minute. Okay. Now here centimeter per minute, na? Now here centimeter per second I require. Centimeter per second I require. For that purpose, what happened? I just divide this my 18 divided by 60, na? So that I am going to get centimeter per second. Right. Now second will get cancelled. I'll get joule per centimeter. Clear, everybody, guys? Right. So be careful while you are solving the units. So now watts is converted into joule per second. Now I require to convert my centimeter per minute into centimeter per second, so that my second will get cancelled, so that I will get joule per centimeter. Now from there I can write it is 25 into 200 into 0.65 is divided by 18 by 60, so that I can get joule per second and also centimeter per second, so that second will get cancelled. I'll get joule per centimeter. Now this 60 will go up, na? Right. Now I'll go for the next slide. Now, so heat input is equal to, it is 25 into 200 into 0.65 into 60 is divided by 18, such that you're going to get it is joule per centimeter. Okay, now I'm going to get here it is kilojoule per centimeter I require na. So that is why if I solve this 10.83 kilojoule per centimeter I'm going to get. Okay, so that is what my so you will get it is joule per centimeter, then you just divide this fellow by 1000, so that you will get it is a kilojoule per centimeter. Clear everybody guys? Okay, understand? Please try to understand. So here nothing there, I'll get in joule per centimeter, I require kilojoule. That is the reason why I just divided by my joules by 1000, so that it is converted into kilojoules. That's what I done. Okay, now what is your answer here? See guys, what is your answer? 10.83. So your answer is here, C is your answer for the first question. Isn't it guys? Clear? Right. Next is what we have to find. Next is the area of the cross section of the well bead in mm square. Okay, it is not mm2, so it is mm square guys. Okay, mm square it is. Okay, right. Now what I'm trying to explain you, the area of the cross section of the well bead you are supposed to find. Okay, right. Now let us go for this area. Now I just hatch this portion. How we will find out that, we will let you know. So I'll use orange, I'll use dark orange. Right. Now I'm supposed to find out this area of the well bead. The hatch portion is your area of the well bead guys. The hatch portion is your area of the well bead. How you are going to find out that area of the well bead? Okay. Okay. Now see, so it is going to be feed certain rate. It is going to be feed certain rate. So rate of filling by the electrode is equal to rate of filled area, isn't it? So here I can write it is rate of melting. Rate of melting of electrode is equal to rate of filling of the electrode, rate of filling of the well bead. Okay, right. Now I'll write it is rate of filling of electrode. Okay, right. I'll write it is right. Now I just write this. Now from the diagram, second question, I'll take blue again. Right. Right. Filling rate of well bead. Filling rate of well bead is equal to, it is filled rate by electrode. Filled rate by electrode. Filled rate by electrode. Isn't it guys? What is that? Filling rate of well bead is divided by is equal to filled rate by electrode. Filling rate. How can we calculate filling rate? Filling rate. Area of the weld bead into velocity of the welding speed, so that I can get a fill rate na. Now I can write it as area of the weld bead, area of weld bead into so it is into guys, let me write that, area of the weld bead into, it is gonna be a, how much it is area of the weld bead by welding speed V, that is equal to filling rate. So that is equal to half d square into F. That is see that, how can I write that? So diameter of the area of the electrode, and also so how much it is going to be melting rate. So melting rate is equal to deposition rate na. So how much it is going to be melt, that is going to be deposited. So how can I write that? Melting rate equal to, it is area into feed rate, so that I can get melting rate. Now area into velocity of the well bead, that is filling rate will come. Okay, right. From there I can write it is so area of the well bead we don't know, so that is what we have to find. Okay, so area of weld bead is equal to, it is a half into d square, 1.2 square. Diameter of the electrode is given na, given in the problem diameter of the electrode. So what is given diameter of the electrode? 1.2 mm. Okay, so where is your electrode? This is your 1.2 mm. That is equal to D. Now what is the feed rate? This is what your feed rate, that is 40 meter. Oh my god, 40 or 4? It's 4 only, 4 meters per minute. Okay, right. Now I just write that 4 meters per minute. Okay, right guys. So because all dimensions are in mm na, you just convert this fellow also meters per second, mm per second. Okay, right. So here I can write this fellow is equal to, it is 4000 is divided by 60 mm per second. All right, now let us go and solve this. Now here my feed rate is 4000 is divided by 60. Okay, so from there I can divide it by welding speed. That is, welding speed is 18 centimeter na, so that is why 18 into 10 centimeter per minute given na, so I just convert that into seconds, centimeter per mm per second. 1 minute, 1 minute. Now here see that welding speed is given how much guys? Welding speed is given 18 centimeter per minute. That is why I'll write it is 180 mm is divided by 60, so that I'll get it is mm per second. Okay guys, clear everybody? Right, now let's go for putting the values in that. Okay, now here it is mm per second. Okay, here also it is mm per second. Okay, now here it is mm square, mm per second will get cancelled na, so 60 will also get cancelled. Now finally my area of the weld bead I am going to get, it is 25.12 mm, 25.2 mm square I am going to get. Okay, so this is how you are supposed to solve this problem. Okay, hope you understand all. Yes guys, understood? Right, area of the weld bead means this hatching area. This hatching area I have calculated. Right, right. Hope you understand. So have a look on the question, then we will move forward. So now 25 point minus, your answer is B. Okay, right. Right, have a look on that another question. Yeah. So have a look on this question, 1 minute. Yeah, welcome guys. Have a look on this question. Two steel bars, let me read the question once. Okay, two steel bars, each of diameter, 1 minute, I'll select the pen. Two steel bars, each diameter 10 mm, okay, are friction welded end to end, an axial pressure of 200 megapascal. Okay, what is that? Two bars are there, so which are having diameter of 10 mm each. So this is, my hand is 1 bar, another hand is 1 bar, and these two bars are coaxially welded like this. Okay. Now diameter of the bar is 10 mm. Okay, that is what given over here. Now at a rotational speed of 4000 rpm, the coefficient of friction between the two faces of the bar is 0.5. The torque is assumed to be 3/4 of radius of the rotating bar. The power in kilowatts consumed at the interface of the welding. Okay. Now I said all of you that guys, whenever you read the question, if you are not able to understand, then you just read again it is. Okay. So once and twice you just read the question. All right. Right. Now let us go for write the given data. So before given write data, what is the welded it is? What type of welding it is? Okay, end to end it is a steel bars are end to end coaxially friction welded. Okay, coaxially friction welded. Okay, you have to know that what is friction welding. Okay, for that purpose, guys, I just draw the small diagram. This is a one bar and it is a another bar. This is a another bar. Okay. Now one bar is fixed now. One bar is fixed and another bar is made to rotate on the fixed one. Another bar is made to rotate on the fixed one. So that what happened? So due to the friction, if this bar is rotating on this bar, then what happened? Friction is going to be generated. Because of the friction, heat will be generated. So after you are getting the sufficient heat, if you apply axial pressure, so that what happened now? So these bars are going to be joined. It is a solid state welding process. Okay, guys. So one bar is fixed, another bar is made to rotate onto the fixed one, so that heat will be generated. After getting the yes, Vijay Sai, I'll teach, not an issue. Okay. Right. Now here another bar is rotated onto the fixed one, so that because of the friction, heat will be generated. So due to that heat, so these whenever you will get the sufficient heat, then you apply some axial pressure and rotation speed is given in the problem. What is the rotation speed here? That is equal to 4000 rpm. Okay. Now axial pressure is equal to how much they gave? 200 megapascal. 200 megapascal is given. And what else given? Coefficient of friction between the two mating parts, mu is given. Mu is equal to 0.5 is given. And what else given? And torque. Torque is equal to acting 3/4 of radius. Torque is going to be act 3/4 of radius. Yes, guys, understood? Right. Now, here what we have to find? For making this joint, how much power you require? That is what you have to calculate. Clear, everybody, guys? First, based on your data of the question, you are supposed to select your particular, you are supposed to select based on the given data, you are supposed to draw the diagram. Accordingly, you can solve your problem. Okay, power we have to calculate. Now, let us go to power. Power required for this operation. Power is equal to, it is 2 pi nt by 60. 2 pi nt by 60 watts. Okay, but in the problem what they ask you, calculate the power in terms of kilowatts, isn't it? Right. Now here I just multiply with 1000, so that I am going to get kilowatts. Yes, guys, understood? Right. Right. Now here, guys, let us, what is torque? Torque is equal to, it is force into distance, that is 3/4 of radius. Okay. Now let us go for back. So the bar diameter they gave na, how much it is? 10 mm. 10 mm diameter is given. Okay. Now the radius is, so radius is become 5. Okay. Now 3/4 of the radius. Okay. Right. Next. Right. Now here force we have to calculate. Now friction force is equal to axial pressure axial pressure into area into coefficient of friction. Isn't it, guys? I just go back. Now I want to frictional force here. How much? So whenever I rotate this bar onto this one, then friction is going to be generated. Now frictional force is going to be act. Now my frictional force is equal to pressure into cross section area. What cross section area? What cross section area? This cross section area. So this pressure is going to be applied on the cross section area of this one, isn't it, guys? Okay. Now my axial pressure into this cross section into mu, so that I can get my frictional force, na? Isn't it, guys? My frictional force. Yes, right. Now let us go for calculating that. Now axial pressure, how much gave axial pressure? Axial pressure 200 megapascal. Yes, na? In the problem they gave, na? So axial pressure is 200 megapascal is given, right? Now let us go to pressure, area of the bar. How can you calculate area of the bar? So it is cylindrical one, na? Pi by 4 d square, right? Now here, so here it is pi by 4 d square. So that is d is how much? 10 square into area is 0.5. So that I can get my frictional force is equal to how much I'm going to get, guys? So if it is possible, calculate. Frictional force I am going to get 7854 newtons. 7854 newtons. Okay. Now what my next job is? I am supposed to calculate force. I can calculate. Now I have to calculate what is that? Torque. Now torque equal to, it is frictional force into 3 by 4th of radius. That is radius is 5 d by 2, na? So our d is this much. Now what is this? Now 7854 into 3 by 4 into 5, such that I am going to get, here it is a newtons and it is a mm, na? Now here I require Newton meter. Okay. So for that purpose, what I do now? I just multiply with this 10 to the power of minus 3, so that I can get in meters, na? Now here I am going to get Newton meter is 29.45 Newton meter is my torque. Yes, guys, understood? Now I got torque. Now only thing is here, power I am supposed to substitute. Clear, everybody? Right. Now let us go for that. Right. So now my power equal to 2 pi nt by 60 into 1000. Why 1000? Kilowatts I require, na? Actually, if I remove this 1000, I'll get in watts. But in the problem, they ask you in kilowatts. For that purpose, I just divide it by with 1000. Okay, most of the students think that why sir divided with 1000. Okay, right? Don't think like that. Now here 2 pi into n is 4000 given, na? 4000 rpm, and your torque is how much, guys? 29.45 Newton meter is divided by 60 into 1000. Okay, such that you are going to get 12.33 kilowatts. Okay, 12.33 kilowatts. Okay, guys. So this is what the how to solve the question. Okay, have a look on the question once, guys. Okay, how to understand the question based on the data is a very, very important, guys. Okay, now here see that two steel bars are coaxially friction welded, end to end. So now one is rotating onto the fixed one, such that friction is going to be generated. Due to that, heat will be generated. This heat will be, whenever you are getting the sufficient heat, you stop your rotation, apply axial pressure, so that joint is going to be formed over here. Okay, joint is going to be formed over here, guys. Clear, everybody? Now from here, what happened now? First I'll calculate the force and then torque, and then I have a formula for power formula. What is that for formula? 2 pi nt by 60. Now why I divided by with 1000? Because I require power in kilowatts. That is why I have calculated. First T, force into distance, but the torque is acting 3 by 4th of the radius. Okay, here look at the problem. The torque is acting 3 by 4th of its radius. That is why here I am taking, so radius into 3 by 4th of the force. So after that I am getting this newtons. Now torque equal to force into distance. So distance is 3 by 4th of radius. Now I want a Newton meter. So that is why Newton meter I can get joule. Okay, that is the reason why I have right. It is a joules are required now, so that I can get this one. Now total power equal to, I can get this 12.33 kilowatt. Clear everybody? Hope you understand the question. Now let us go for the next question. Yeah, have a look on this question. Yeah, welcome back guys. So have a look on this question. During TIG welding process, the arc current and arc voltage are, let me take pen. Hope you enjoy the session guys. Okay, so nice problems and good conceptual things we are discussing. Okay, right, now let us go for during TIG welding. TIG welding means tungsten inert gas welding process. The arc current and arc voltage is given. Arc current is 50 amperes, arc voltage is 60 volts respectively. When the during welding speed was 150 meters per mm per minute. Okay, in another process, the TIG welding carried out at the welding speed of this much 120 mm per minute at the same, see here I just drag this down, at the same voltage and heat input, at the same voltage and heat input. Okay, so at the same voltage and same the input, heat input to the material, so that weld quality remains same. The welding current in the for this process is, welding current in the process is, you are supposed to calculate. Clear everybody guys? Okay, here two TIG welding processes are going happen in a simultaneous way. That means in a simultaneous way two welding processes are going happen. Okay, right. Now one welding parameters are given, that is the welding speed is given, welding current is given, arc voltage is given, right. Now so the same welding is going to be happen, welding speed and voltage, heat input are, welding voltage and heat input are same. Okay, so for the first case, what is the V? V is equal to 60 volts and I is equal to 50 amperes, and welding speed is equal to how much guys? How much guys welding speed? 150 mm per minute. 150 mm per minute. Yes guys. Alright. Now in the second case, what happened? In the second case also, the welding speed is 120 mm per minute, and what they gave, at the same voltage and heat input, at the same voltage and heat input, this welding speed is going to be happen at the same. So first case welding voltage and first case heat input. Okay, now what we have to find for this process, welding current we have to find. Okay, now I can write heat input in the first case is equal to heat input in case 1 is equal to heat input in case 2. Okay, right. So what they gave, heat input V into I is divided by welding speed, case 1. Now here V into I is divided by welding speed, isn't it, guys? Okay, so heat input in the first case is equal to heat input in the second case. Yes, guys. Now from here, what I am supposed to do? So first case voltage is given now. What is that? Voltage 60 volts and 50 volts, 50 ampere current. 60 volts and 50 ampere current is divided by 120 mm per minute. 120 or 150? First case. First case is 150. I'm sorry. 150. And second case. What in the second case they have said? At the same voltage and heat input. So voltage is also equal. That is also 60 volts. Isn't it, guys? Okay. Now from there I can write it is 60 volts into current is divided by 120. From there you just find the current, that is equal to 60 into 50 into 120 is divided by 150 into 60. So that 60 will get cancelled and 5 3 just okay. Now here I equal to it is 120 is divided by 3. Now I equal to it is 40 amperes. Okay. Now find your answer here. Where is 40 amperes? A is your answer. Clear, everybody? Hope you understand this question, guys. Okay. Thank you all. So now let us go for next question. Yeah, have a look on this question. Welcome back, guys. Have a question on that. A spot welding of two steel sheets each 2 mm thickness carried out successfully by passing 4 kilo ampere current. 4 kilo ampere current. Okay. Now, right. Now what is that? A spot welding is going to be happened in between the two sheets of 2 mm thickness carried out at a current of 4 kilo ampere current. Okay, right. Now for time is 0.2 seconds through the electrodes. The resulting weld nugget formed between the two sheets is 5 mm in diameter, assuming cylindrical shape, and its diameter is given how much? 5 mm. Okay, guys, right. Now the thickness of the nugget is in mm. The thickness you are supposed to find. Clear, everybody? So now for that purpose they gave that properties of the sheet is latent heat of fusion is 1400 kilojoule per kg, and effective resistance of the weld joint is 200 micro ohms, and density of the steel is 8000 kg per meter cube. Okay, clear, everybody, guys? Okay. Now let us go for solve this question. Okay, right. Now here what they gave? Two steel sheets are spot welded. Oh my god. Two steel sheets are spot welded like this. Now the weld nugget formed is cylindrical shape. They said in the problem. Yes, the weld nugget formed is cylindrical shape. Okay, between the two sheets, right? Now here weld nugget is in cylindrical shape. Weld nugget is in cylindrical shape, which is happened over here, right, guys? Right, cylindrical shape, and also they gave diameter. Diameter of this fellow is nugget is 5 mm. Okay. Now we have to find height. Height of the nugget we have to find, guys. Yes. So it is not B, guys. Height. It is not B. It is height. H. All right. H we have to find. Now what is the given process parameters? So 2 mm thickness. Right. I'll write 2 mm thickness here. Each two sheets are 2 mm thick. 2 mm thick. Okay, this is also 2 mm thick. Now let us go for what are the things else given. I'll write the given data. Right. Now current equal to how much I gave current? 4 kilo ampere. Right. Now that is why it is 4000 amperes. Okay. Now time equal to 0.2 seconds, and so resistance is given. Resistance is given. Yeah. So here resistance, effective resistance is 200 micro ohms. Okay. Right. Now resistance R equal to, here it is 200 micro ohms, that is equal to 200 into 10 to the power of minus 6 ohms. Yes, guys, understood everybody? Okay, right. Now heat generation you calculate. Heat generation equal to, what is that in resistance welding? I square RT. Yes, guys, are sleeping? Get up, get up. Okay, so we are at the end. Now 4000 square into R is 200 into 10 to the power of minus 6 into T, 0.2 seconds na T. Yeah, so now if I solve that, I am going to get it is 640 joule. 640 joule I am going to get. Okay, so thank you Vijay Kumar, thank you. So nice teaching, sir. Thank you very much. Paddu also very good. Thank you very much, madam. Okay, thank you very much. Right. Now 640 joules. Next is heat requirement. So heat requirement for this weld. Okay. So for forming this spot weld or nugget, how much heat we require, that we are supposed to calculate. Okay. Now heat requirement is equal to heat required to produce nugget is is equal to, what is that? Mass of the nugget into, sorry, not it is not mass flow rate, it is a mass. Mass of the nugget into sensible heat plus latent heat of melting. Mass I can write density into volume of nugget into sensible heat means Cp delta T plus latent heat. Okay, but in the problem no specific heat is mentioned, isn't it? No specific heat is mentioned in the problem. Have a look on the problem. Have a look on the problem, guys. No specific heat is mentioned. So only they gave that only latent heat is given. That means for forming this particular spot welding, they use only latent heat. They are not using so specific heat. That is why we can neglect this terminology. We can neglect this terminology. Okay, right, guys. Now let us go. Oh my God. Now, so I can write my heat requirement. I can write my heat requirement is equal to, here it is rho into volume of the nugget into latent heat of melting. Okay. Now rho given in the problem na. So rho is given in the problem na. Density of the steel 8000 kg per meter cube. Right. Now here 8000 kg per meter cube into volume of nugget. Volume of nugget is cylindrical shape given in the problem, right? We have already discussed cylindrical shape is given. Yes, guys, please do respond. Right now here pi by 4 d is given na 5 centimeter square into h we don't know, but here my density is in meter cube. That is why I converted my volume into meter cube, because it is in mm, it is in mm, so that I can get it is minus 10 to the power of 9. Oh, not 19 guys, 9. 10 to the power of minus 9 into latent heat. So how much latent heat is given? Latent heat is given 1400 kilojoule per kg, right? 1400 kilojoule per kg. That is why 1400 into 10 to the power of 3 joule per kg. Isn't it, guys? Now heat requirement, this is. Now in this case you are supposed to consider heat generation is equal to heat requirement. Okay. So such that here heat requirement is, heat generation is 640. Heat generation is 640 we have calculated. Heat requirement is 8000 into pi by 4 into 5 square into h into 10 to the power of minus 9 into 1400 into 10 to the power of 3, like this. Okay. Now only h is unknown parameter. If you solve this, h you are going to get 2.91 mm. Clear, everybody? So like that you are supposed to calculate. So heat requirement is equal to, here it is mass of the nugget into sensible heat into latent heat. Now if the sensible heat parameters are not given, then immediately you just convert, remove that term and you only consider the latent heat, guys. Clear, everybody? Hope you understand the solution. So whenever these parameters I square is equal to heat generation equal to I square RT na. So whenever it is not given, whenever I square RT and I square RT is equal to rho into LH into specific heat, in this terminology anyone is missing, we just equate heat generation equal to heat requirement, so that you can find the different, what is that, you can find the whichever the missing parameter you can find. So that is what all about the session today. And now let me go for some advertisement of, right. So live, so new batch announcement, guys. So now let us go for those people who are enjoyed this session. Now go for this right, new batch. So live online new batch will be start on date January 3rd 2023, and first subject is for ECE EEE instrumentation, signals and systems, and signals and systems. Now in mechanical and civil you will get engineering mechanics. CSE is equal to, it is TOC will start. Now Saturday on January 7th another batch will start for online networking for this one, and it is FM and hydrology, and also operating system for the CS. Okay. So those people who wants to contact, then you may contact with this numbers, so that our team will come and touch with you. So we have online GATE classes and also hybrid classes and also classroom classes as well. So if you wants to enjoy the if you wants to enjoy, or if you want to crack the GATE, then definitely you have to approach the IMS GATE. We have a we have a confidence that we are contributing the 70% success people into the GATE examination. Okay, right. Now classroom new batch. So January 8th, so Sunday, for ECE EEE and instrumentation, digital, and ME and CE is a SOM, and CS is a digital will start. So now the address is Jayanagar Gate number 41, 4th floor, and South End Road, Basavanagudi, Bangalore, and landmark is above Adiswar Supermarket. Okay. Now we may contact these numbers as well. Okay. So this is what the classroom offline centers. Okay. Now for hybrid classes means it's a mixing of offline and online. So 70% of offline classes and 30% of online classes. Okay. Now for that new batch will start on January 3rd, Saturday, signal systems for ECE and mechanical, ECE EEE and instrumentation, signals and systems, and mechanical and civil engineering mechanics. Next Saturday, January 8th, 2023, control systems and also FM and hydraulics. So address is same, so third floor, BOI building, opposite Modern Supermarket, Ben Circle, Vijayawada. Okay, this is from hybrid classroom for Vijayawada session, and you may contact these numbers, guys. Okay. Now, hope you enjoy the session. Then whatever the things we have discussed, so I have collected all the typical questions and difficulty questions, so that I guess if you are preparing the casting and welding, these problems are definitely helpful for you to enhance your confidence levels. Okay. So now all of you, thank you very much for you guys for your patient listen, and thank you for supporting me and well good comments and likes also. Thank you all of you. Thank you very much. We will meet in the next session. Thank you.